Hey guys, in this lecture I'm going to show you how to set up your development environment so that you can follow along in these courses. First, let's talk about operating systems. The three big ones are Windows, Linux, and Mac. Most, but not all of my courses are part of the deep learning series. Eventually, the deep learning models we're going to build will become so complex that we will need specialized libraries like Theano and TensorFlow to implement them. Now, as of today, Theano and TensorFlow are not officially supported on Windows. So if you are interested in deep learning, you will discover pretty soon that there is not much you can do without a ton of work. Even working with non-GPU enabled libraries like NumPy and Matplotlib can be a challenge, but these are at least possible on Windows. If you really must use Windows and have your Python environment inside Windows, and you don't want to try the virtual machine method, which I'm going to discuss next, then one good library I know of is called Anaconda. You can get Anaconda at continuum.io/downloads. I can't vouch for this 100% because I haven't used it myself, but I've known others who have found it at least usable. Now I'm telling you this from experience. I've worked with a ton of clients one-on-one, and Python development, especially when it involves the NumPy SciPy stack, is not easy when it's on Windows. The method I'm going to describe using virtual machines will work on most modern computers, and as of right now, if you want to do any deep learning stuff, whether that be with Theano or TensorFlow, you cannot do this on Windows. With that out of the way, I'm going to quickly go over which courses I've released so far or plan to release in the near future that do not require Theano and TensorFlow, so it's possible to do on Windows. With these in mind, you can decide if you want to install a virtual machine or not, but I would highly recommend it because it's free and everyone can follow the same instructions. So we've got linear regression in Python, logistic regression in Python, which are the prerequisites to deep learning part 1. Then we have deep learning in Python part 1, which is mostly in NumPy and a little bit of TensorFlow. We've got easy natural language processing in Python, data analytics, SQL for noobs, beginners, and marketers, cluster analysis and unsupervised machine learning in Python, and unsupervised machine learning, hidden Markov models in Python. This course is going to have a little bit of Theano in it. Next, here are some courses that depend heavily upon Theano or TensorFlow or both. We've got practical deep learning in Theano and TensorFlow, convolutional neural networks in Python, unsupervised deep learning in Python, and recurrent neural networks in Python. As you can see, a lot of interesting and complex stuff can be done in Theano and TensorFlow. Alright, so hopefully I've convinced you that using a virtual machine is a good idea. Windows is a great operating system, but it tends to not be as developer friendly since it tries to be more consumer friendly. Note that if you're on a Mac, this probably isn't necessary. You can just install NumPy, SciPy, Pandas, Matplotlib, Theano, and TensorFlow using easy installer pip. Sometimes this stuff can fail depending on the many combinations of versions of each thing that are possible, but usually just Googling your error message will lead you to the right solution on Stack Overflow. If you're on a Mac, you can just do sudo pip install NumPy, SciPy, IPython, Pandas, Matplotlib, and Theano. Alternatively, you can use easy install, which might have a more recent version. You may need to use easy install to install pip itself, which is just sudo easy install pip. If you want to install TensorFlow, just copy the command at tensorflow.org. It's just a pip install command that points to their custom installation location. I won't put it here since it corresponds to a specific version, and that version may become out of date by the time you watch this. That is good news because the people working on TensorFlow are updating it all the time. Alright, so if you've made it this far, that means you want to install a virtual machine with Linux on Windows, or that you're already using Linux and you want to know what commands to use to install these libraries. We are going to need two things to start for this tutorial: VirtualBox and a lightweight version of Ubuntu. I would recommend Xubuntu or Lubuntu. I'm going to use the 64-bit version of Lubuntu for this tutorial. So download these first and then return to the tutorial. Alright, so now that you've got VirtualBox installed, we're going to create a new machine with 64-bit Lubuntu. So you want to hit New, type in a name for your machine. And this stuff is already correct. I'm going to choose 2 gigs of memory. You can choose more memory if your computer has more memory. I'm going to create a virtual hard disk now. I'm going to choose dynamically allocated, and 8 gigs is good enough for this example. Alright, so I'm going to go to settings. If we go to storage, you can choose the ISO file that you downloaded. So I'm going to load up the Lubuntu ISO that you downloaded from lubuntu.net. Alright, so hit OK and hit start. Okay, so it's going to take you through the installation of Lubuntu. So you want to hit install. Alright, so Lubuntu is going to take you through some prompts. Alright, so you want to erase disk and install Ubuntu, and I'm not going to check any of these. Just hit continue. Alright, so once that's done, it's going to ask you to restart. So just hit restart now. Alright, now that you're in the machine, what I always like to do, if you notice how this window is too big for my Mac window, you can make the inner window resizable by installing guest editions. And this also lets you do useful things like cut and paste between machines. So you want to open a terminal. You go to System Tools, select LX Terminal. Now I'm going to cd into that folder. Cool, so the correct command was sudo /vboxlinuxeditions.run. Notice how there was something that failed in there, so we need to install GCC. So you want to run sudo apt-get update, and then run sudo apt-get upgrade. So the next thing is you want to sudo apt-get install build essential. Alright, once you've done that, we can try to run VBox Editions again. So that's sudo /vbox linux. Alright, so everything worked this time, so we're going to restart this machine. Alright, so now the window is only as big as I want to drag it. Okay, so now we can install the actual data science stuff. So you want to open again LX terminal, do a sudo apt-get update again. Now you want to install, it's a long list, so Python NumPy, Python SciPy, Python matplotlib, IPython, Python pip, Python dev, and Python setup tools. Just hit yes. Alright, so now that that's installed, you can test it out. You can type in IPython. So IPython is open. Import NumPy. NumPy is working. Import SciPy. Import pandas. Right, we don't have pandas yet. We will install that next. Import matplotlib. Cool, so we have everything we've installed so far. So now we're going to install pandas and Theano. So that's pip install ---- upgrade pandas Theano. Alright, so now we've got Theano. The last thing we need is TensorFlow. To get this, you guys want to go to the TensorFlow website and just grab the latest command, since they're updating the package all the time. So let's open a browser. Let's search for install TensorFlow. Alright, so you take this code, copy it, you paste it into here. Alright, now you've got Theano and TensorFlow. You can test them out. Go to github.com/lazyprogrammer/machine learning examples. Alright, so you need Git if you want to check out this code with Git. So let's install Git. Alright, so let's run our clone command again. Let's try the HTTPS version. Okay, so this one works. Alright, so use CD into machine learning examples. Go into ANN class 2. So this has some introductory TensorFlow and Theano code. So just run Python theano1.py, since this does not require any data. Cool, so it seems everything is working. Now let's try the TensorFlow example. So it's TensorFlow 1. Alright, so you want to make sure you install the correct TensorFlow. You want the CPU only version. Hopefully it just overwrites the other version without any trouble. Cool, so let's try the example again. Super, so now everything is working. Now if you want, there is a text editor that I highly recommend. It's called Sublime Text. So you hit download. You go to Ubuntu 64-bit. You save this. And it will automatically be installed. Alright, so now you have the exact same text editor that I use in my lectures. So you open machine learning examples, and this is all of our code. Hey everyone, and welcome back to this class. In this lecture, I'm going to go over a better way to install data science and machine learning libraries for Python for Windows users. Historically, Windows users have had a lot of problems installing this stuff. Luckily, these days there is an option that makes things very painless and just as easy as they are on Linux or Mac. That is Anaconda. In fact, even if you're not on Windows, you can still use Anaconda. It's nice because it isolates your environment from the defaults provided on your system. So for example, you can have Python 3 in Anaconda, but Python 2 as your system default. When I first started these courses, I wasn't keen on Windows since there were a few essential libraries that couldn't be installed on Windows without a significant amount of effort, if at all. In my view, anything beyond a couple of lines in the console or clicking an install file is too much. And believe me, some students even have trouble with that, so it's good not to make things too complicated before you can even begin the course. Nowadays, that has changed. It's a lot easier to install things on Windows, in large part thanks to Anaconda. And so this lecture is all about how to install all the data science and machine learning libraries you'll need on Windows using Anaconda. So in this lecture, I'm going to walk you through how to install Anaconda as well as some of the libraries you might need that don't already come with Anaconda. You'll find that most of the common libraries such as NumPy and SciPy are already included, so if that's all you want to use, then for you it's just a one-click install. On this slide, I'm going to give you a super short summarized version of this lecture, so you don't have to walk through the installation with me if you don't want to. For some people, that really helps since you can see it, but if you can do it on your own, feel free. So, number 1, download and install Anaconda. This is just a one-click install. It already includes NumPy, SciPy, Matplotlib, and Pandas. That's all we need for the NumPy stack in Python, linear regression, and logistic regression, and a few more courses. It also comes with NLTK, which is what we use for NLP, and scikit-learn, which has some pre-built machine learning models. Now, even though this stuff comes by default, you can still update them if you want. So you can do conda update NumPy, for example, and that will update NumPy. Number 2, install deep learning libraries. We've got pip install TensorFlow, that's going to install TensorFlow. And if you want to install Keras, you have to first do conda install pip, which is going to update pip, and then you can install Keras using pip install Keras. If you don't update pip first, you might get an error. Next we have CNTK, which is Microsoft's deep learning library. So you do pip install and then the CNTK URL, which you can get from Microsoft's website. So I'm not posting any URL here because the version could likely change in the future. And so you just Google search how to install CNTK and you can get a URL just like this. Next we have PyTorch. That's pip install -c peterjc123 PyTorch. After that we have Theano. So that's conda install Theano or conda install Theano PyGPU if you have an NVIDIA GPU and you've installed the CUDA toolkit already. Number 3, install OpenAI Gym. That's just pip install Gym. If you want to be able to play Atari games also, then that's more involved, so just skip to the end of this lecture where I walk you through that. If you want to play and save videos using OpenAI Gym, then you also have to install FFmpeg. So the first thing we're going to do is go over to the Anaconda website. That's anaconda.com/download. Scroll down to the Windows section and click on either Python 3.6 or Python 2.7. Or if you're watching this lecture in the future and there's a new version, get that. The code in my courses is compatible with both Python 2 and Python 3, so in that regard, it doesn't really matter which one you get. In the lectures, you might see Python 2 code, but the best way to make sure you're seeing the latest version is to git pull inside the course repo. So make sure you're always doing that because I'm constantly making new updates. Now, although Python 3 is newer, there are still reasons to use Python 2. For example, in your work, you might use Python 2, or certain platforms like Google App Engine only support Python 2. So if you're running a web app there, that means you're stuck with Python 2. It does have great scalability features, so there are many good reasons to use Google App Engine. If you want to get more insight on whether to choose Python 2 or Python 3, just check out the appendix lecture, Python 2 versus Python 3. So now that we've downloaded the install file, all we need to do is click on it. That's what I mean by one-click install. You click on this, hit OK a few times, and everything is done. Unfortunately, I gave my username a space, which kind of sucks, but that's what happened. So I'm sure some of you have a space in your username too, so if I come across any issues, at least you'll know what to do. Alright, so everything's installed. So essentially everything except the deep learning libraries have already been automatically installed. So you don't need to manually install NumPy, SciPy, Matplotlib, Pandas, IPython, or scikit-learn. So if you're taking my NumPy course or any course that doesn't use modern deep learning libraries, you already have everything you need. So let's go into IPython and make sure that's the case. To start IPython, I go to the Start menu, type in Anaconda, and then this Anaconda prompt application should pop up. Actually, it should pop up before you even finish typing Anaconda. So we go into there, and this brings up a command line terminal. Next, just type in IPython. After that, we can import all the libraries I mentioned earlier. If we don't get an error, that means they've been installed successfully. So let's try something simple like generating some random numbers and making a plot. Okay, so that's a plot of random noise. Let's make a histogram too. Okay, so we see a normal curve just like we expect. Now you can see that TensorFlow is not installed, which is why we get this error. But we can install it very easily by exiting IPython and then typing in pip install TensorFlow. Next, let's try to install Keras. So we get this error. So I looked this up and determined that we need to update pip. So let's do that by typing in conda install pip. Conda kind of works like pip in that way. They are all just tools for installing stuff. Okay, now let's try pip install Keras again. Alright, so everything works. Next, let's try to install NLTK. This is used in my NLP courses. So it looks like it's already installed, so there's nothing more to do. Just keep in mind, if we come across a library you don't care about, feel free to ignore it. I find it's useful just to install everything at the same time so that when you're deep in the code later, you don't have to think about stuff like this. So the next thing we'll install is CNTK. This is Microsoft's deep learning library. Notice how it's not part of pip, so you need to grab the URL manually from Microsoft's website. Unfortunately, it's a little hard to find because there are many pages that deal with how to install CNTK on Microsoft's website, but what you're looking for is a page that has a link to a WHL file. So copy and paste that after pip install. This is a good example because it shows you another way you can use pip by doing pip install and then a URL. Next, let's install PyTorch. This requires us to use a custom source, so we have to specify the option -c peterjc123. So that's conda install -c peterjc123 PyTorch. This is because a very nice guy called peterjc123 has provided us with a version of PyTorch that works on Windows. Now once that's all done, we can verify that they've been installed correctly by going back to IPython. Alright, so TensorFlow works. Keras works. NLTK works. CNTK works. And Torch works. Next, let's install Theano. Theano has historically been pretty difficult to install on Windows, but nowadays, that's not the case. So if you go to their website, you'll see a bunch of instructions. If you don't want to use the GPU or you don't have a GPU, then the instructions will be very easy. I don't have a GPU on this machine, so I'm going to do the easy version. Keep in mind that Theano is really great for learning purposes, so it's totally fine, even if you have a GPU, to just install the CPU version for now and then use the GPU version of TensorFlow. Now I ended up upgrading MKL service and libpython since that's what they told me to do on Theano's website, but it looked like these were already installed. In fact, updating MKL service gave me an issue later, so we'll have to fix that. So if you want to install Theano for CPU only, that's conda install Theano. If you want to install Theano for the GPU, then do conda install Theano PyGPU. Now let me go into IPython and check if Theano works. So we get an error because of this MKL service thing that I mentioned earlier. So let's set this environment variable it's telling me to set. By the way, this is great to know if you don't yet know how to set environment variables on Windows. We can also check that it worked by using the echo command. So let's try that again. Let's do a simple example of adding two numbers in Theano, just to make sure everything's working. If you want to do something even more complicated, you can run this script from Deep Learning Part 2, which doesn't require any external dataset. So just go over to the folder ANN class 2 and type in python gridsearch.py. So that's going to look for hyperparameters using cross-validation. Now in this last section of this lecture, we're going to talk about reinforcement learning. When we start studying reinforcement learning, there is yet another library we'll need to install called OpenAI Gym. If you don't plan on learning reinforcement learning, you can skip this part of the lecture. This has also historically been very difficult, but luckily the open source community has put in the work so you don't have to. You're welcome to read through the GitHub issue on this if you want, but I'm going to just do the simplest thing that works. So let's first do pip install gym. Great, so that worked. Now the second command is a bit longer, so let's go to the actual GitHub issue and copy and paste the command. The easiest way to get there is just to go to Google and type in install OpenAI Gym Windows Anaconda or something along those lines. So let's paste that in. And notice how it fails since I haven't yet installed Git. So we can install Git by doing conda install Git. Now let's try it again. Unfortunately, this fails again because we need GCC, which is a C compiler. Now, one way to get GCC is to do conda install m2w64 toolchain. But unfortunately, I tried this and it also doesn't work. In fact, I think this toolchain was installed already. So I tried quite a few things that didn't work. So in order to save you some time, I'm going to recommend you only try the stuff on this page if everything else doesn't work for you. So what worked for me was to just grab the precompiled binary directly. Now in order to do that, you'll want to go to Cojoli's GitHub repo directly. So that's this URL here, github.com/Cojoli/Atari-Pi/releases. Next, you'll want to download the WH file that matches your environment. So I have Python 3.6 on a 64-bit installation of Windows, so this is the file I want. Luckily, we already discussed earlier in this lecture how to install a WH file. That's just pip install and then the path to the file. So let's do that. Now we can test our installation by running a script that requires an Atari game. So let's cd over to RL2 and then Atari, and now let's run dqn_tf.py. Cool, so everything's good. Now the final thing we want to do for OpenAI Gym is, if you want to play a video or save a video, you want to install FFmpeg. So to do that, you want to type in conda install -c menpo ffmpeg. Once you've done that, you can go to the cartpool folder and type in python saveavideo.py, and this will run a script that will play the cartpool game, show a plot, and then save a video. And of course, you can also play this video by just navigating to the file and clicking on it. So for now, that's everything. If I need to add new libraries or updates to this lecture, they will be appended at the end. So in this lecture, I'm going to explain how to set up your deep learning libraries to make use of the GPU on your home laptop or desktop. This video is a companion lecture to my blog post, which you can find at lazyprogrammer.me. Now, of course, you don't have to memorize this URL or try to type it out manually. Instead, you can just go to the top of the page where the navigation bar is and click the link that says Machine Learning and Data Science. Then you scroll down to the section called Practical Issues, where you will find a link to this post. There are a ton of useful links in this post, so you'll probably want to follow along in your browser as I walk you through it. So I'll give you a minute to click on this link so that you're viewing this post in your browser, and then you can come back when you're ready. So in my second deep learning course, Deep Learning Part 2, I originally discussed how to set up a GPU-based instance on Amazon Web Services. This is nice because you can choose a pre-built image which has everything already installed for you. The only thing you need to do is copy your script to the machine and then run it. However, depending on your needs, that might become expensive. On Amazon Web Services, you are billed by the second. So you might consider getting your own machine with a GPU to run your deep learning scripts. The upside to this is that you pay a flat fee, which is the computer itself. The downside to this is that you have to install everything yourself. So this lecture is all about how do you go through this entire process of choosing the right machine, and then once you have your machine, how do you install everything? So this is a lecture I've wanted to make for a long time, but I've always put it off because it's not a straightforward process and things are always changing and breaking. So it was a matter of, how do I write this lecture in such a way that it won't become out of date? As usual, you have to learn my rule, learn the principles, not the syntax. The goal of this lecture is to learn the high-level steps. The details will always be in flux, and there's nothing you can do about that. So I don't want you coming to me and saying, hey, I copied and pasted this line from your tutorial, but it didn't work. My answer is going to be, of course it's not. I told you these things are always changing. So you must be principles-based and not syntax-based. If you're just copying commands without thinking, that's not the right approach. The right approach is to complete each of the high-level steps, and if one method doesn't work, then try another and another and another until it does work. So hopefully this lecture helps you understand these high-level principles. I'm also going to share with you a bunch of stories about how things might go wrong to demonstrate to you that unexpected problems can and will happen. It's just the nature of the game. You might install something and you might follow those instructions perfectly, and then your computer just won't start. That can happen. So it's important for you to keep an open mind and realize that these things will happen, and do not get scared or intimidated when things go wrong. Remember that I didn't invent any of these technologies, I'm just passing along information.
So if something does go wrong, your best bet is to Google your problem and see if anyone else has encountered it. Coming to me with your problem probably won't help you because I don't have the same computer as you, and I'm probably going to be using a different version of everything. So let's start with the basics. Why do you need this guide? Well, if you're a beginner, you may have presumed that all you need to do is just buy a laptop with a GPU, and all of a sudden your deep learning libraries will be GPU accelerated. This is incorrect. There are two reasons this is incorrect. First, you need to have a specific kind of GPU, the kind made by NVIDIA. Second, you need to have special software that works with the GPU, one of which is the GPU driver. Now, a lot of you younger folks these days probably have zero idea of what a driver is. A driver is low-level software that interacts with hardware. In the old days, any device you plugged into your computer would require a driver. For example, if you wanted to plug in a printer, you'd have to install a driver. If you wanted to plug in an external USB hard drive or a USB webcam, you would need to install drivers. In other words, a driver is software that allows your computer and external hardware to talk to each other. And that's exactly what we have here. Your computer needs to talk to the GPU, and it doesn't know how to do that automatically. In fact, there is an entire stack of software that you need in order to leverage the GPU for deep learning. The idea of the stack helps us organize high-level things and low-level things. So at the lowest level, we have hardware. That includes things like the GPU, printers, webcams, and so forth. On top of that, as mentioned, we have drivers, which allow the computer to talk to the hardware. In our case, the driver is called CUDA. After skipping a few steps, we have the software that we use, such as TensorFlow, PyTorch, and Keras. In fact, Keras is even higher level than TensorFlow because it's built on top of TensorFlow. So generally speaking, the higher level you go, the simpler your code is, but you also have less flexibility. Long story short, buying just any laptop with any GPU will not work. Instead, you have to buy the right laptop with the right GPU, and on top of that, you have to install the right drivers and the right software. In other words, your entire stack has to be correct. If you mess up any of these steps, then it won't work. So we're going to start at the lowest level, the hardware. To keep things simple, I'm going to assume that you'll be buying a laptop. There are gaming forums out there if you're the type of person that wants to build your own PC from scratch. However, I'm going to assume that you do not want to fiddle around with hardware because that's a completely different topic than what we are discussing in this course. It's important to note that GPUs are not created equal. You must buy a laptop with an NVIDIA GPU. That means no AMD and no Intel. You'll notice that there are some laptops out there that come with mobile GPUs and have an M in the name. For example, the GTX 950M. These are okay, but the 900Ms tend to not have enough RAM, and they're not as fast. Personally, I would want a GPU with at least 4 gigs of RAM. The more RAM you have, the larger your batch sizes can be. So to that end, I'm going to recommend a few laptops. Specifically, I would recommend Lenovo or Dell, with a slight preference for Lenovo. The reason for this is that Lenovo machines usually work very well with Linux. Now you might wonder, why do I care about using Linux? I'll discuss this more later in this lecture. For now, let's continue looking at these laptops. So first we have a Lenovo IdeaPad. It has a 15-inch screen, 8 gigs of RAM, 512 gig SSD, and a GTX 1650 for the GPU. Notably, the price is just under $700, which is pretty good. On the downside, 8 gigs of RAM is on the lower end these days, and the processor is only an i5. You'll get much better performance on an i7. Next, we have what is essentially the same computer, but with a different configuration. So this one has 16 gigs of RAM and an i7 processor, but only 256 gigs of SSD space, which is personally too small for my needs. Importantly though, it has the same GPU. This is also a few $100s more expensive than the first laptop, so you're really paying for that RAM and the faster processor. Next we have what I think is the best option out of the ones I've looked at, which is a Lenovo Legion. This one has an i7 processor, 24 gigs of RAM, a 1TB hard drive, and a 512GB SSD. And it has the same GPU as the other laptops we looked at. On top of that, it's nearly the same price as the previous laptop, still under $1,000. Finally, for contrast, I've listed a Dell machine. This one's got an i7 processor, 16 gigs of RAM, a 1TB SSD, and the same GPU as above. Unfortunately, the price of this machine is nearly double the Lenovo machine, so you're really paying for that ultra high definition touchscreen. Personally, that's not something I care about, so it's not something I would want to pay for. Now, you might be wondering, if you watch my videos, you'll notice that most of my videos are made on a Mac. Unfortunately, these days, Macs are no good for deep learning. The CUDA drivers we're about to discuss are no longer made for Macs, so effectively, NVIDIA is no longer supporting the Mac. And if you recall, I said everything in the stack has to work together. So if you're trying to install the newest version of TensorFlow, it's not going to work with an old version of CUDA. You might think, well, you're pretty good with these things, so you'll just compile TensorFlow from the source code. Well, I spent a day on that before I gave up, so that's something you might want to take into consideration. Okay, so at this point, you've chosen your laptop. Your laptop has arrived in the mail. Awesome. You have a new, super fast, super performant computer for deep learning. Now you have an important decision to make. What operating system should you use? Most of these machines come with Windows 10, but you'll always hear me recommending Linux. So why is that? Should you replace Windows with Linux? What are the trade-offs? At this point, I want to remind you of my motto, learn the principles, not the syntax. So what are the important principles here? Now again, a lot of you probably haven't been around long enough to have experienced this firsthand, so you have to rely on my experience. And my experience is that, in general, things aren't built for Windows right off the bat. If you're a Windows user, you'll usually have to wait some time before you can use the same software libraries that your Linux counterparts have already been using for months or years. Of course, you shouldn't just believe what I say without real, concrete examples. Luckily, I have plenty. So, when I first started working with clients, one major hurdle was installing the NumPy stack. Those basic libraries that these days you don't even have to install at all. So NumPy, Matplotlib, Pandas, and SciPy. Usually it would take hours to find and run custom Windows installers. These days you can just download Anaconda and everything just works, but remember that it took years for that to come out. Another example is Theano, which was the original deep learning library that came with automatic differentiation and GPU acceleration. It's important to remember that for a long time, Theano was the only deep learning library around. There was no such thing as TensorFlow or PyTorch. So again, it took years before you could install Theano on Windows without having to spend all day on it. And even then, you would be lucky if you got things working. Now you might think, whatever, I don't care about Theano, Theano is dead. But you're forgetting that the same thing happened with TensorFlow and PyTorch. When these libraries came out, they also did not work on Windows for a very long time. Now these days, you might not care because Theano, TensorFlow, and PyTorch now all have Windows support, but not so fast. What about other libraries, such as OpenAI Gym, which is what you'll need if you're doing reinforcement learning? Again, limited support for Windows. So it's up to you what you want to use based on these historical facts. Should we use lessons from history to guide our future decisions? I think most people would agree that's usually a good idea. On the other hand, there are good reasons to use Windows as well. For one, installing things on Windows is usually much easier than on Linux. You usually don't have to mess around with a terminal. Most things are just click and go. If you get one of the Lenovo laptops I recommended previously, then you don't even have to install CUDA. It already comes pre-installed. On top of that, the CUDA driver comes with a nice user interface. So whenever you want to update CUDA, all you have to do is open the user interface and click a few buttons. You don't have such nice conveniences in Linux. However, you'll have to remember that CUDA is not the only thing you need. You still need to install cuDNN, which is less easy. This involves downloading a zip file, copying the contents to specific folders, and setting environment variables. Ultimately, whether you use Windows or Linux, you'll want to remember that there are two packages from NVIDIA that you'll need to install, CUDA and cuDNN. So first you install CUDA, and then you install cuDNN. Now, if you're having trouble deciding whether you want to use Windows or Linux, you don't have to. Another option, which is the one I prefer, is to simply have both. This is called dual booting. If you got the Lenovo laptop I mentioned above, it's actually quite nice because it comes with two drives. So you can use the SSD to hold the operating systems, and then you can use the spinning disk for your data. Alternatively, you could use a separate drive for each operating system. If this is what you're interested in, there are a lot of tutorials out there that will walk you through the process. But these days it's pretty easy, so you might not even need a tutorial. Since your computer comes with Windows pre-installed, you only need to install Linux. To do that, you just need to plug in your Linux installer on a USB stick and click a few buttons. Just a warning though, make sure you don't erase your entire disk and overwrite Windows. You want to choose the option to have Windows alongside Linux at the same time. So the next section here is all about how to install CUDA and cuDNN on Linux. Personally, I would recommend installing a Linux distribution that's Ubuntu or Debian based. That includes other distributions such as Pop! OS, Linux Mint, Xubuntu, Lubuntu, and Kubuntu. The reason why is because these tend to have the most support and the largest community. So if you're having problems, it'll be easier to find help. Now this section really highlights the downsides of working with Linux. Not only is it more difficult to install CUDA and cuDNN compared to Windows, there are many things that can randomly go wrong. I'm going to share a few examples with you, just to help you understand what might happen. So one thing that happened to me was, I tried installing CUDA on Linux Mint, but after installing it, I couldn't boot into the OS after restarting. So that was obviously a no-go because you can't use your computer if you can't even turn it on. This was unfortunate because I really like Linux Mint. Another operating system I tried was Pop! OS. Pop! OS is made by a company called System76, which makes their own laptops that also come with NVIDIA GPUs. It turns out that they have their own way of installing CUDA drivers, which is attractive because it's just a few simple commands. Unfortunately, those commands didn't work. In any case, the method that works for me most consistently is to use the instructions from NVIDIA's own website. So first you have to install CUDA. So you go to developer.nvidia.com/CUDA downloads. Then you select a few options specific to your system. So if you're on Ubuntu, you'll choose Linux, 64-bit, Ubuntu, and so on. Then you get a link to a deb file. Once you've downloaded that, you can install it just like how you install all deb files. Just use the command sudo dpkg-i and then the file name. Next, you'll have to install cuDNN. Again, the instructions on NVIDIA's website are what worked for me consistently. Basically, it's just a few commands, but I've pasted an example here so you know what it should look like. If you're watching this in the future, you should obviously check NVIDIA's instructions to make sure that you get the most recent version of these commands. Now for completion's sake, I also have a section here for Windows, even though we kind of already discussed it. As mentioned, if you got one of the laptops above, your Windows installation should have already come with CUDA. But if it didn't, you can use the same link as above, developer.nvidia.com/CUDA downloads. This time you choose Windows and then you get an exe file. As usual, installing with exe files is super easy. You just click on it and then follow the prompts. Next, you'll need to install cuDNN. As mentioned previously, this is currently a bit more complicated than just clicking an exe file, so click on the link to go to the NVIDIA site and do what they tell you to do. Remember that these instructions may change, but currently they involve downloading a zip file, unzipping that file, placing the resulting files in various directories, and setting some environment variables. Alright, so now that we've taken care of the hardware and the low-level drivers, we can move up the stack. The first library we're going to look at how to install is TensorFlow. Lucky for you, installing these libraries is now a lot easier than it used to be. For TensorFlow, traditionally you would have two commands, one for the CPU version and one for the GPU version, and you'd have to pick the right one for your system. For this tutorial, obviously the right one would be the GPU version. However, with the most recent version of TensorFlow, TensorFlow 2.1, you can just do a pip install TensorFlow, and this automatically gives you a GPU-capable version of TensorFlow. You can check whether or not TensorFlow is using the GPU by going into Python, importing TensorFlow, and then calling tf.test.isGPUavailable. Next we have PyTorch. Again, it's just a simple pip command, pip install torch. No difference between the CPU and GPU. If you want to check whether or not PyTorch is using the GPU, you can run these commands and you should get a similar output. Next we have Keras. Since Keras works on top of TensorFlow or Theano, you don't have to do anything special. Keras is installed as usual, just pip install Keras. You just have to make sure that whatever backend you're using, whether that's TensorFlow or Theano, that they are GPU enabled. Finally, we have Theano. Today, with libraries like TensorFlow and PyTorch going higher level, it's difficult to get a good feel for what actually happens inside a neural network. There's too much distance between the theory and the code, so you might not understand why you need all those equations we learn about, even though those equations are what actually happen in the neural network. So Theano is great for understanding what it means to build a computational graph and why Keras has that compile step. For Theano, my recommendation today is to use Anaconda, whether you are on Windows, Linux, or Mac. Installing Theano is just the simple command, conda install Theano. If you want GPU capabilities, you'll also want to install PyGPU, which can be done with Anaconda as well. Alright, so there you have it. Now you know how to set up a GPU-enabled deep learning machine from start to finish at every layer of the stack. You learned how to choose the right laptop, the pros and cons of each operating system, how to install all the necessary drivers, and how to install deep learning libraries so that they make use of the GPU. As I mentioned earlier, you have to make sure that you have the right version of everything, since they all have to match. For example, the latest version of TensorFlow or PyTorch won't work with older versions of CUDA. If you're installing everything from scratch and you're just getting the latest version of everything, you should be fine. Otherwise, you'll want to check the release notes on GitHub to see which versions of each component you need. The last thing I want to mention in this lecture is that I will not be answering questions on the Q&A or via email about troubleshooting your setup. This would be nearly impossible since I'm not there with you physically. I don't have the same computer you have, and even if I did, the software I have might be a different version than what you have. I would consider this to be a consulting service, so if you really wanted my help on this, you would have to hire me as a consultant. At the same time, my current availability is very limited, and I probably wouldn't accept such a job, nor would you want to pay hundreds of dollars per hour for it. So your best bet if you need help troubleshooting is to check Google, and most likely someone else will have encountered the same problem as you. If not, then you should start a new thread on Stack Overflow or a similar forum, and somebody who solved the same problem before can assist you.